guys, welcome back to another one of our virtual labs. So today we are going to look at the densities of liquids and see how alcohol compares to water. So first off, I've got some tools here. These are graduated cylinders, if you haven't run into these before. It's a cylinder shape. The graduated part means that there's a scale on here where it is marked out in milliliters. This is a relatively small graduated cylinder. It goes up to 50 milliliters, which is exactly the amount that we're going to be using for this lab. I've also have 2 clear cups, a couple of tea light candles, some water here in a beaker, just tap water, and some alcohol. This is 91% rubbing alcohol. It's a little more concentrated alcohol content than what you normally buy at a drugstore for use at home. All right, so first step, we need to get some water and some alcohol into these 2 cups here. So I'm going to start off with my water. I want 50 milliliters. Use a funnel here and try not to make a horrendous mess. Turn it to face me for a second so I can see if I'm on that mark or not. So when you're using one of these, because it's a cylinder shape, there's a curve to it. So it's actually kind of bowed, like my hand is bowed right now. You can see there's a little bit of a curve there. That's called a meniscus. And you want to mark the level of the water at the lowest point of the meniscus here. Let me see if I can get something behind it so you can see it. So I'm going to go just another drop here. Turn it to face me so I can see the meniscus. And way too much. That didn't work. I should have left it alone. So what I'm going to do is I'm going to be a proper scientist. I'm going to use a transfer pipette. This is just like an eyedropper. It's called a transfer pipette. It's a small pipe. There's the pipette part. And the transfer part is that I'm going to transfer liquid from one thing to another. So the way you use these, if you've never used one before, is you squeeze it to take the air out, put the tip in the water, and release the bulb up here. So I'm not squeezing anymore, and that sucks the water up. And then, let me see if I can get to our 50 without going over here. There we go. All right, got it that time. Clear the rest of the water out of this in case I need it for alcohol. All right, so this graduated cylinder is our water. I'm going to put that 50 milliliters in that cup. All right, so this side's water. On this side, we're going to use alcohol. Get it up close here, and I'm going to finish it up again with the pipette. Get to where I can see that. This is probably going to take more than one pipette to get to the 50. Just a touch more. And just a touch more. Okay. Clear the pipette. I'll have to rinse that with some water here. That's right into the sink to get all the alcohol out of it. Now alcohol would just evaporate, but it's green colored alcohol, so I don't want the pipette to be all green, so that's why I'm making sure I wash it all out. All right, close that up. And now I have 50 milliliters of rubbing alcohol. So let's just be clear about scientific terms here when we're doing this. The word alcohol gets used a lot in our culture because we have a lot of drinking of alcohol in our culture. This is a completely different type of alcohol. It's a rubbing alcohol. If you were to drink this, it could easily kill you. So this is a very, very toxic substance, whereas alcohol that you drink, liquor, it might be a more accurate name for it, is not deadly. Not that it's good for you, but it's not deadly. So don't drink this stuff. Alcohol is not alcohol. They're not the same thing. We should use different words for them. All right, so I've got water here, that's a clear one. I have rubbing alcohol here, that is the green one. All right, now what we're gonna do is see if a candle will float on the surface of both of them. So I've taken the candles out of their little aluminum cups. I'm popping the wicks out so that that's not a factor. All right, here's my tea candle of wax, and I'm setting it in the cup there. And you can see that that is floating, but there's space underneath of it. All right, now let's take a look at our alcohol here, because it's the same kind of tea candle here. Loop. Well, that rascal went right to the bottom. So what would make the same exact sample of wax float in one substance but sink in the other substance? So hopefully you're thinking, do these two liquids have the same densities? Because you know that the wax candle in this cup and the wax candle in this cup have the same densities. They're the same exact thing. They're identical. They're manufactured by a machine, and they're as identical as can be. So the densities of these are the same. So it must be the densities of the liquids that are different. Well, let's see. How can we test that? I'm going to move these back where you can still see them, so you know there's no hocus pocus going on. I'm going to bring out our balance here. Get that where you can see it. Here is our water and our alcohol on the balance. The cups are centered. And what do you notice? If you look at the scale here, you know, it's not measuring in grams or ounces or pounds or anything, but it does show you which way the scale is tilted. Plus, you can just visually see that this side is lower than this side over here. So again, this is water, this is alcohol. So what would you say? Is water more dense than rubbing alcohol? Think about that for a second. All right, let me set these aside for a minute. Move our balance for a minute. And we have our student activity sheet here that you need to be working through while you watch these kind of things that we do each day. And the sheet will take you so far from what we've talked about just through 1 and 2, just down to this area here. We're going to talk about this part of the sheet in the next demonstration that we do. Thanks for hanging out. All right, guys, we're back with another one of our demonstration labs looking at the densities of liquids. And we have our graduated cylinder here. Again, this is our fairly small one, only goes up to 50 milliliters. And we're going to make a density column, this is called. Let me just shake some of that liquid out of there. All right, so I'm gonna start off with just some tap water. I'll turn this so I can see it. gonna put about, 15 milliliters of water in there. And we're not gonna be weighing this or doing any intricate measurements, so it's okay. I'm not having to worry about the meniscus so much. If we were trying to find the actual density of the liquid, which we're gonna do in just a couple minutes, but not with this setup, then I'd have to really be hitting that meniscus so I know exactly how much I have. So I'm comparing apples to apples when I do that. But this is going to be more of a layering process here, so I'm not worried as much about that. All right, so I've got water in there. Next, I'm going to add about 15 milliliters of vegetable oil. Again, turn it so I can see the scale. And 15 and 15 is 30, so I'm going to go up to 30. Well, maybe I'm going to go up to 32. Whoops. All right. So see if you can see anything going on here. Make our observations, right? I mean, that's important stuff that we do inside. And then finally, I'm gonna put about 15 milliliters of alcohol. Again, this is the 91% rubbing alcohol that we used in our last demonstration. So 15 and 15 and 15 is 45, so I'm gonna stop at 45 so that we have equal amounts, close enough to equal amounts of all these three liquids. And you might be noticing that these three liquids are behaving very, very strangely here. Why do you think that might be? I've got water and I've got vegetable oil and I've got alcohol in this tube, and they're not mixing. So think about why that might be. Let me turn this a little bit so that the measurements are not obscured or showing up in the camera as much. Why do you think we might be getting that kind of layering? All right, so on our sheet, now we're at the bottom of our activity sheet answering these questions here. The teacher showed you a graduated cylinder with alcohol, oil, and water. Why does the alcohol float on the oil? Why does the water sink below the oil? So again, that's what we're seeing here. The alcohol is green, it's on top, the oil is in the middle, and the water is at the bottom. And I can shake it around a little bit, and that's not going to change anything. It's going to still stay there. All right, turning the activity sheet over. We are going to move on to our next phase here, where we're going to be measuring the density of the liquids that we just worked with. So to do that, I have a scale here. Make sure I've got that where you can see it fine. And on our scale, we're going to use graduated cylinder. This is empty. I'm going to put that on the scale, and I'm going to slide this until we get a balance here. Easiest if I do that at the bottom so I can lift it a little bit. Yeah, the 100's too much. Thought it might be. All right, so let's go by 10s. 70, 80, 90's too much. Kick it back here to 80, and then all right, so what I'm seeing here is I've got 89.5 grams. Let me see if I can zoom in, make sure you can see that. This is gonna be a challenge because I can't see the phone, but let's see what we can do here. All right, so I've got 80 here, and 9.5 on that part of the scale. So that graduated cylinder, empty, weighs 89.5 grams. Now we need to write that down on the table part of our activity sheet. So again, that is down here on our activity sheet, the table down here, this is what we're going to be filling out. So massive graduated cylinder, massive empty graduated cylinder, we need to write that down. Moving on now. Dump out some liquids here out of my graduated cylinder. All right, so we're keeping that measurement because we're going to need to be subtracting that measurement. And we're going to now find the density of water. And we are using 20 milliliters of water for this part of the lab. And this time we've got to be really, really dead on because we are weighing this. So it's not okay to just eyeball it like we did with the density column. All right, so I'm looking at the meniscus. And again, the lowest point of the meniscus is what I want on that line. There we go. All right, so you can see here, well, maybe you can't. You can see here that I am at 20 milliliters at the bottom of the meniscus. And again, the meniscus is this kind of curved shape, almost like my hand here, that the water is higher on the sides of the glass than it is right in the center. So we measure by the center. That's the meniscus. All right, so let's see, what does 20 milliliters of water weigh? So put that on the scale. I'm gonna go ahead and zero this back out. And since we're at 89.5, it's pretty safe to assume that we're gonna go over 100 now with 20 milliliters of water in here. So I'm gonna start off by moving the big unit up to 100. Now I'm gonna move my 10s. Nope, 20 is too much. Back to 10. 10's too much. Go with our small units. And I'm watching out here for that to be at 0, so I'm a little heavy, even though I'm really, really close. Okay, coming back the other way just a touch. And just a touch back. One more. And one more. All right, I don't think we're gonna get any closer than that, but I'm gonna try. So right now we're at 108.2 grams. My big old hands here, just keep knocking it all around. See if that makes it any better. All right, 108.1 grams. All right, so that's water, and we need to record that now on the table of our student activity sheet. One hundred and 8.1. So we'll show you the first one here as I'm working it with you. So I've got at the top here, this is what my graduated cylinder with the liquid in it weighs. This is how much we got from weighing the graduated cylinder empty. Now we're going to be subtracting to find out what the mass of the liquid is, because we want to take away the weight of the cylinder, right? We don't want to be adding that in. So 108 minus 20 is 88.1. All right, so you should look something like that, and I'll let you work the rest of them on your own here. I'm not going to do them all with you, but we will work through the rest of the lab together. All right, so we've measured our water here. Pour the water out of the graduated cylinder. Now we're going to do alcohol, and again looking for 20 milliliters. All right, and I'm going to take it up the rest of the way with the pipette. Okay, there we are with 20 milliliters of alcohol. Take the funnel off, that would be cheating. Add that weight in there. Okay, and let's see what this weighs. I'm going to start back at 0 again. Not a big deal to do that, but just keep the experiment clean. I'm going to start it over again. You might have a memory of whether alcohol or water is heavier. We just weigh water, so that might give you a clue as to what you could have done with these, but we're going to start from scratch just so it's as clear as we can make it. All right, let's check it at 100 ounces. That works. Can we go to 110? No. All right, so here we go, back to our ones again. Start at 5 and see where we need to go from there. Ooh, it's looking good so far. I think we got lucky right on the top. All right, so we've got 100 ounces, 105 ounces right on the money there. So that's what we're going to record on our table now, 105. And this is alcohol, so that's the second column. Written down my graduated cylinder amount right underneath of it in this column here. And then we do the math the rest of the way down. You wouldn't do that. I'm not going to do it out loud now. It's your turn. I'm not finding the density of the liquids yet, the bottom row there. We'll do that in just a minute. Let's do this part of the lab first. All right, I'm going to pour the alcohol out. And now we're going to use the vegetable oil. And if you're doing any of this kind of thing at home, it's really important that you do the vegetable oil last, because it's really hard to get the oil out of these things. It takes some seriously hot water to do that. So this is going to be hard to clean. So I'd have a contaminated cylinder with oil in my water, oil in my alcohol, had I done the oil first. So that's why the oil has to go last here. And I'm not wanting to put the transfer pipette into this stuff because I'll never get it out of there. So I'm going to try really hard to go drop at a time here and get us up to the 20. More time ought to do it. more time. I might be being silly here. It might have been worth just throwing the transfer pipette away. All right, that's got it. Ha, got lucky on that one. It was right at 20. There we go. So let's see what 20 milliliters of oil now weighs. I had not reset the scale, so you saw that the scale just tipped when I set that on there. So you can make some thoughts about that, some conclusions about that. So here we are at 100. I don't think we can go to 200, but let's see what happens. Nah, way too much. So back to 100. Let's try our tens unit here. Can we go to 50? Too much. 30, too much. 20 is too much. Even 10's too much. Okay. So let's try our ones here. If you're thinking about the density column, you might have had some estimates of where we could have started, and I didn't bother with that because I didn't want to slant your thinking on this. I wanted to just do it straight up measuring. But if you think back about the density column that we had going on with the three liquids all in the same cylinder, you could have made a guess as to where you'd be starting this off. So here we are at 100 ounces, 106 ounces, 106.5 ounces, and we are now balanced on our scale. So I'm recording 106 ounces. Is that right? 106.5. Subtract our 20. And then you should have your numbers across all three columns for the first three rows. We don't have the density of liquid yet. All right, let's wrap up our table now. So for the last thing we need to do is to calculate the actual density. So if you remember from earlier, density is mass divided by volume. Density is mass over volume is the way we've written it, or M over V. So you can now calculate these things by dividing mass by the volume. And remember, our volume was 20 milliliters. And go ahead and calculate those for each of these things on that column, and then you'll be done with this step, and we can move on to the next step. So what we have, this is the molecular structure of the items that we were just working with. So the top one is oil, here's water, and here's alcohol. So you can see that they are similar in some ways, but they are not the same. Oil is more dense than alcohol is, alcohol down here at the bottom again, but it's less dense than water. The molecules that make up oil are larger than those that make up water, so they can't pack as tightly together as the water molecules can. You can see that when you're looking at these two. And they take up more space per unit area so that they're less dense. So kind of like aluminum, we were talking about aluminum the other day with solids, there's just some space in there. Or when we were looking at our wax candles from the other day, you know, they seem like they are a solid, compact thing, and technically, scientifically they are, but there's space in there at the molecular level. If we got all the way down to where we're looking at atoms, there'd be space in there. So oil is the same way. The water molecules are packed closely together than the longer molecules that make up oil here. The oxygen atoms in the water are smaller and heavier than the carbon atoms that are in the oil, and this makes the water more dense than the oil. And then finally, alcohol down here at the bottom. Even though the molecules that make up alcohol contain a heavier oxygen atom, alcohol is less dense than oil because alcohol molecules do not pack closely together. And you can see in the picture there that there is space amongst all the molecules. All right, we can continue on down our student worksheet now on this page. And here we are looking at number 4, how do the densities you calculate explain why water sinks in oil and alcohol floats in oil? So again, you're thinking back to the density column in our graduated cylinder when we had all 3 liquids in the same cylinder, but then you're using the information from the table that we just did. This table at the bottom of this page to help you answer that question. And then you're also completing this table here, thinking about, again, the density column. Now we're ready to move on to the next section. Oh, I'm sorry, you can answer it down here too. So you just finished that up on your own. You can pause the video and take care of that. I'm gonna keep going here as I'm recording, but you stop, finish all that up, and then when you're ready, start again, and we'll be moving on. All right, so here we have just plain water in a cup. Here I've got a carrot. I'm gonna cut a slice off this carrot. Set that aside. So here's just a slice of carrot. And what we're going to do with that is look at whether the carrot is more dense than water or not. Actually, I'm going to change the cups out here real quick because the measurement markings on the beaker here are really showing up in the video, and that's going to make it hard to see what's happening. All right, so here's the carrot. Do you think it's going to sink or is it going to float? Let's see what happens. All right, as you can see, it sank to the bottom. It's sitting there on the bottom. So which is heavier? Which is more dense is the actual question. Sorry, not heavier. Which is more dense? A slice of carrot or water? Now let's do a magic trick. I have here some salt, and I'm going to pour in about a teaspoon of salt. Stir it into our cup here. So keep your eye on the carrot. It's moving around a little bit here because I am stirring. Let's just watch what happens. Well, it was doing it. You can see that the carrot's traveling around in there. Let's see if I can come up over the top and show you a little bit better. So the carrot is traveling in here. It is not sitting on the bottom anymore. It's not floating on the top yet either. But what do you think would have changed so that it's not sitting hard up against the bottom like it was a minute ago? A little more salt in. We'll make soup here in a minute. I've got a carrot, got salt and water. And now, if you take a look at that, what do you see going on? The carrot is floating at the surface. So what changed? Well, I added some salt to the water and some piece of debris, apparently. I added some salt to the water. So think about what actually changed, what shifted, so that now that is carrot slice is floating in the water instead of laying on the bottom. So again, back to our activity sheet here, your student activity sheet. You can answer question 7 and 8 and 9 and 10. So you can take it all the way down to the bottom of the page. All right, so we've looked at how salt affected the density of pure water, or as pure as we're going to get coming out of a tap. So again, here I've taken the salt out. This is fresh water in here now, new water, and I have removed the carrot. So this is just pure water straight out of the tap. Here's an interesting thought experiment. Here's a piece of ice. The ice is also pure water, right? It's made straight out of the tap. This is just a change of state. Here it is in liquid state. Here it is in the solid state. That's where I wanted it to go anyway. But have a look at that now. Why is the ice floating on top of the water? If the water in liquid state is pure water and the ice in the frozen state is pure water, what can you say about the density of these as it changes state, that the ice is floating in the water instead of laying on the bottom or floating halfway down or wherever else it could be, having the same density as the liquid state? So what do you think is going on there?